Okay, so today we're going to be talking about vocabulary with 3D figures. So first of all, 3D figure is called a solid, and you can think about them in two major categories. The first one would be, are any of the sides curved? And if so, think about like a cone, a hemisphere, a cylinder. Okay, sorry as that spins. Those are going to be hemisphere, which is half of a sphere, and then a sphere right here. Those are going to be special, okay? And the ones that we're going to focus on today are going to be the ones that don't have curved sides. We're going to be focusing on something called a polyhedron. And so a polyhedron is going to be a 3D shape that doesn't have any curved sides. And the plural of polyhedron is going to be a polyhedra. And so um, let's kind of look at some of the vocabulary that goes along with those figures. So they are made up of some polygons, okay, that form together. And when you place them together, they will meet at an edge, okay. And so here's an edge right here. And so this is made up of rectangles and squares, it looks like. And they're put together, and where the two sides meet, that's an edge. And then also you will see that at the corners where there are three different faces that meet, you would have a vertex. Okay, the plural of a vertex is a vertex. Um, and so those are the three main words, face or base. We'll talk about the difference between this and that. Those are the flat surfaces. And the faces or bases are going to be um, absolutely like a square or rectangle, and you would name it with letters. If you name an edge, you talk about the two letters, like it could be segment AB, okay, AB, and put a segment over it. A vertex, you're going to see like, oh, point A is a vertex, okay. And so remember, with shapes, you can either write the word or you can use the symbol if they have one for it, okay. A diagonal, you can have a diagonal of a side, or you can have a diagonal through the figure. And so diagonals are nice. We're going to talk about two main shapes, a prism, and we're going to talk about a pyramid. It's a little tricky because I don't have my hands to demonstrate in class. Think about holding your hands together like you're holding symbols, okay? And if you stretch them apart, you can form a shape that's between those two figures. So if you take two triangles, you have to start with two congruent figures, and if you stretch them apart, you can form a 3D shape between those two items. And so think about this. If you start with two triangles, okay, they got to be congruent, and if you stretch them apart like an accordion, you will form a triangular prism. Okay, and that's formed with those two bases, the two congruent figures, and then also the sides that go around it. Okay, and so this one right here starts with two squares, okay, and then you stretch your hands apart and you can form a 3D figure. This is a rectangular prism. Why? Because you start with two rectangles and you stretch those apart and you form a six-sided figure that's called a rectangular prism. If you start with two pentagons, okay, and then you stretch them apart, okay, start with them together, stretch them apart, that's going to be a pentagonal prism. A hexagonal prism is going to be formed if you've got a hexagon, and then you stretch it apart. And so the bases are going to be the original figures that are going to be congruent, and then you stretch those apart to form a prism. And so you can start with two pentagons, you can start with two triangles, but those two shapes that are identical are going to be the name of the figure as well as the bases of that figure. The sides that are between those two bases, like around the edges, are called the lateral faces. And so you've got the vertices, which are the little corners. You've got the seams where they meet. Those are going to be called edges. And so they're called and then there's two different kinds of edges. We're not going to make a huge distinction between lateral, which is going to be around the edges, and then base edges, which are going to be around the base. But that's the truth there. If you look at a prism, notice this is a triangular prism because you start with two triangles together and you stretch those apart like an accordion. And the area formed by that is going to be a prism, a triangular prism. We've got a right prism, and as you can tell, there's a right angle formed between the bases and the lines that connect them. If you have an oblique one, it's going to be diagonal. Okay, somebody first hour talked about it being like you got hit by a car. Okay, you hit a post, it's kind of leaning over. That is absolutely true. Okay, so the next thing we're going to talk about would be over here. Okay, some more vocabulary. The second shape is a pyramid. A pyramid has just one base, okay, whereas a prism has two congruent bases that you stretch apart. A pyramid has just one, and you can pull up from it and make all those connect to a single point called the apex at the very top. And so, yeah, the point at the very top is called an apex. It's one of the vertices, and then you'll have edges, and the bottom is the base. Okay, if you set it upright. The sides around it are called the faces. Okay, just like you got a face on your sides, the base is on the bottom, the faces are on the edge. And within a pyramid, you're going to have a base, and then you're going to have a vertical height to the very top of the figure. And that's going to be directly from the base, perpendicular to the base, up to the very top of the figure. The slant height is going to be along that triangle. And so it kind of is technically the height of that face along the edge, but it's not really the height of the figure. The height of the figure is actually from the bottom up to the top. And so one thing I want you to think about would be, if you draw the height, you draw the slant height, this actually forms a right triangle. And we can do the Pythagorean theorem with those three sides. And so, likely that'll show up this chapter. Okay, next thing would be, what's the difference? What's a regular pyramid? Well, a regular polygon has all the sides congruent. Well, a regular pyramid has all the bases congruent to each other. So if you're talking about this triangle having congruent sides, this would be an equilateral triangle and then up to the top. And so that would be a regular triangular pyramid. A regular square pyramid would have all four sides at the bottom congruent and then up to a point. Okay, this is a pentagon. A regular pentagon has all five sides congruent. A hexagon has all six sides congruent if it's regular. And they shouldn't be like slanted, okay? A regular one means the bases are the same and it goes up at a right angle. And so as compared to an irregular, where the base doesn't have congruent sides. And so a right pyramid, as you can tell compared to oblique, quite honestly, the very top of a pyramid it's a vertex, but it's called the apex. And then if you drop something, it would directly land in the bottom there. That's a right rectangle. Notice it makes a right angle with the base. Well, every altitude has to form a right angle with the base. So that's not the big deal. But if you drop something like a little rock into this figure, you would notice it would land in the center with it. Okay, so the oblique pyramids are slanted off to the side. And so their altitude, their height does not go right to the center of it. And notice over here, like the altitude here is actually outside of the figure. Okay, it always has to be at a right angle to the base, but there you go. Also, prisms and pyramids are both named for the bases. Prisms have two bases that are congruent, and then again, they're stretched apart like an accordion, okay? And then pyramids just have one base, and that's how you name it, to say, hey, it's a rectangular pyramid. And notice, like, this pentagonal one pyramid is going to be oblique because it's slanted to the side. You name them by their bases, both of these things. Okay. Let's see where the next page is going to be. Here's where I ask students to be like, okay, can you kind of picture what you see here? If you cut those out, what shape would you make? And so if you want to pause and kind of think for a second, what shapes would you get if you cut those out and paste them together? Well, this would be a triangular pyramid, okay? And so you would notice if you cut this out, you would get a triangular base and it would make a pyramid. This next one's a little tricky, but it would make a cone. Okay, so if you cut out this little man, okay, it would look like a cone. I can show you tomorrow in class if you want to ask me. The next one is a rectangular prism, or it could be a cube because it looks like all the sides are congruent, doesn't it? The last one is going to be a cylinder. Okay, so if you cut that out. So we're working with our idea about like space and spatial recognition. And so the next guys, what name are they? And then also if you did a cross section, if you sliced the figure, and then kind of lifted up the top and said, okay, what shape do I see with that? The first figure would be a pentagonal pyramid. And then when you sliced it, if you kind of sent a plane through that figure at that point and lifted up the lid, you would notice it's a pentagon. Okay, and so the name of the next one would be a hexagonal prism. And if you sliced it right down the middle, like that yellow color says, you would get a hexagon. Number 7 would be a cone. And when you sliced it vertically, it would make a triangle. The last one, number 8, talks about what would you have if you had this part right here. And that, it looks like it'd be a pyramid. It's not. Notice it doesn't go to a point. It's a triangular prism, okay? A triangular prism, because you notice this triangle is the base on the top, okay? And so you can see it is a triangular prism right there and right here. And then the feature, if it gets sliced from top to bottom, it's going to be a rectangle. So there you go. And then just in summary, look at these shapes. Notice prisms have identical bases, and then you just stretch them apart like an accordion. So this is a pentagonal pyramid. This is a rectangular, prism, sorry, pentagonal prism, and this is going to be a rectangular prism. This probably looks like a cube, actually. And if all the sides are congruent, then absolutely it would be a cube. The first one is going to be a rectangular prism. You can see the other pieces. On the back, we're going to talk about how would you name these? Like, what's going on here? And so if you want to name a vertex, it's a point. An edge is a segment. The faces are going to be the polygons that you see that form them. And then the bases, again, are also polygons. And so if you want to list these, you're like, okay, what is this? This is a pentagonal pyramid. The vertices are points. And so you would say, okay, it would be points, and then you list them out. It would be A, B, C, D, E, F. Okay, those are all the points that would be vertices. The edges are going to be where the two faces meet. And so there are going to be 10 of them. Okay, and so we don't want to list them all, but the edges are segments. And so like some of them would be like AE. And you either write the word AE or segment AE, or just write the two letters. You could do ED all the way around the whole bottom, and then also the vertical one, or the slanted ones that are going to be like from A to F. You could do A to F, E to F, D to F, C to F, B to F, etc. The faces, how many are there? There are not 6, there's 5. Okay, there are 5 lateral faces around the top, but the bottom is going to be a base. And so the base on the bottom, okay, remember we call it by its base name. So this is a pentagonal pyramid. And so this base is going to be a pentagon. So you can write the word pentagon, or you may draw one, okay? Okay, so the base is a pentagon. And then the faces, what shape are they? Well, they're triangles. And so anytime you're doing a shape, you need to either tell the word that the shape is or draw a picture. So this is triangle, AFE. There's a triangle. So that's a triangle. You could do ABF. There are how many faces? There are 5. And so you can list all the triangles that make those faces, those lateral faces. And the only base it has is going to be the bottom in that case. So looking at the next question, what shape is this? Well, this is a triangular prism. Why? Well, because these two bases are going to be triangles, and then they're stretched accordion-like apart. And so when you talk about the vertices, you would write points. I don't know why I'm writing with a highlighter, but the points, and you could list out each of the points. You would say points A, B, C, E, F, D, and you list each one of these out, okay? And then the edges would be, there are 3, 6, 9. There are 9 edges, okay? And so you can list some of these out. And so like you could do like BC, you could talk about EF. There are going to be 9. So go ahead and list out each of those things. The bases are going to be those triangles. And so the triangles are going to be the bases. So it'd be A, B, C, and then also triangle EFD. And then the faces are going to be the ones in the middle. So those would be rectangles, and you can list out like BEFC. There's 2 other ones. You could do a rectangle CFADA, and you could do the third one as well. Okay, so that's kind of how you talk about the pieces of that. This is going to be either a cube or a rectangular prism. If you know the sides are congruent, you could call it a cube. But if you don't know, you should probably call it a rectangular prism. And you can open it two different ways. And so the bases could be both sides. It could be the top and the bottom. So you kind of just choose, which two bases you want to call as the bases. And then the ones around the middle would be called the faces. The vertices, again, are the corners. And then the edges would be every single one of these edges, like CG and HF. Make sure you label those as segments. All right. Thank you. Have a good day. Your homework is going to be a quizzes activity.